Welcome to part 2, where we actually talk about scripting, as in the scripting systems that are going to enable our gameplay developers to express themselves and create a unique experience based on our generic engine. Let's start with where we've come from as a class. We've all taken ITP485 video game programming, and in there we used C++ to program the code. Many of us have also used C# in Unity to create customized code. Maybe if you've played with Roblox ever, you will have learned that it uses a scripting language called Lua, which is another option. And then finally, if you've done any Unreal programming, then you have experience with a visual scripting language called Blueprint. Let's start with the one we all know, C++. What are the pros and cons of doing your unique gameplay in C++ like we did in video game programming? Well, let's start with the pros. This is the fastest possible execution time. C++ compiled code executes, in general, faster than any of the other scripting options. Also, we get compile time error checking. It can be frustrating to get an error when you compile. A syntax error, you forgot a semicolon. It can be frustrating, but you know what's even more frustrating is to not be told that you've you've made a typo until you actually boot up the game, you play through it, you make your way through the level to the new piece of gameplay you just implemented, and only then do you get the error message saying, hey, by the way, you have a typo here, you got to start all over. So compile time error checking is definitely your friend. What are the downsides? What are the downsides of C++? The longest possible iteration time. So we have to type all the code, we have to compile the code, link the code, launch the code, and only then do we get to see what we just did. So iterating, making a change and trying it, make a change and trying it, is the longest possible turnaround time. Presumably, C++ is the hardest of the languages to learn. We've seen that over and over, mostly because of the pointers that we have so much trouble with. Presumably, if you're in here in this class with us, then you've mastered C++, but it does sort of create a barrier. So many designers who don't have the experience or the formal training in programming languages might not be able to really get in there and express themselves in C++ as easily as some of the other options. Next up, it crashes. What if you do mess up your pointers? You know what's going to happen. You're going to get exceptions. It's going to crash. You're going to bring the whole system down, and that's never a good thing. Sometimes those sneaky little crashes don't happen all the time, and maybe they happen once in a while. It may actually make it all the way out into production before you notice, and it's going to crash on the customer, and that's not good. Finally, speaking of iteration time, the holy grail of iteration time is live update, where you can make a change while the game is playing, and the game will continue playing with your change to really boost that iteration time to next to nothing. And C++ is highly unlikely to support anything like that. What's next? Our next baby step there we mentioned was like C# in Unity. That's a compiled scripting language, but it's not C++. So what are the pros? We still have our compile time error checking. C# is potentially, at least, easier to write than C++, and I think that's definitely true. The lack of pointers, the lack of having to clean up for yourself really makes it a lot easier to use than raw C++. And also, we find it crashes less severely or less often, a full crash. When C# is running within the Unity framework, you can crash a script, and then that script will stop executing, and you get an error message, but the entire game does not stop. So it makes it a little bit less severe to have one of those little crashes sitting in there. Cons, it's not quite as fast as C++, but it is close. Still, unfortunately, not really likely to support live update. Certainly if you're using it in something like Unity, no live update going to be there. As an example of live update, you can move objects around in the editor while you're playing, but if you update the code, that's not going to work. The other con here, it's interesting that garbage collection is kind of a pro and a con. Up here, this is the main reason why C# is so much easier to write than C++, is because it has garbage collection. But here I've got it down as a con, and that's because it creates stalls. Garbage collection takes time. The idea of garbage collection is instead of deleting your pointers when you're done with them, you just stop using them. And eventually the system's going to decide, hey, I need some more memory. I'm just going to go take out the trash. Unfortunately, that means the system says, hold everything, stop the game while I take out the trash. And it can take a long time. Depending on your system, it can take an absorbently long time. I've seen garbage collection spikes over 60 milliseconds for a single frame of garbage collection, and that's going to completely blow your frame rate. If we're trying to run 60 frames per second, we only have 16 milliseconds to work with. If the game pauses for 60 milliseconds while it's collecting the trash, that's going to cause hiccups and hitches that where the noticeable little stalls in the game. Next up on our list was Lua. I mentioned Lua as an example of an interpreted script. An interpreted script is where it's not compiled ahead of time. We actually load in the ASCII characters. We load in the text file, parse that in real time, and then execute on what's in there. So what are the pros? An interpreted script is extremely crash resistant. It's hard to crash something like that. You can make the script stop working, but the system usually can just move on to the next script, give you a notification of this script has some kind of error, but we're going to keep on going. The whole game is not going to go down. It's possible, since it's just a text file, it's quite possible to support live update with something like this, which means you're running along, you encounter a syntax error in your code. What do? Hey, let's fix it. Let's fix it, save it, tell the system to reload that file. It'll reload that file and re-execute that script without having to shut down the whole game and start over. So it's possible that could work. Keeping in mind that these scripts often have state in them, state that's built up over events that you've done throughout the play have caused variables to change. You've changed the state of your variables by playing, and now you've changed the meaning of the code, and that can create a non sequitur that doesn't make any sense now. So keep that in mind. But of our options, the ability to do live update is a big plus. Now, next I say presumably, something like Lua is the easiest of the languages to write and learn, but I do say it's debatable. Everybody's going to have their own experiences. For example, many of you started with C++ as your first language. Some of you started with Python as your first language. I started with C before I ever learned Lua. And that means learning Lua is going to have a learning curve. It's fairly easy to learn, but you still have to go through that process. If you already know C++, transitioning to C#, pretty easy. Doing C++, very easy. Learning Lua, hey, that's not hard, but it's still going to be a learning curve for you. On the other hand, if somebody has no background at all, and this is going to be their first language, perhaps then Lua is easier for them, and that can reduce the barrier to entry. What about the cons? Well, C++ was as fast as you can go, and interpreted script is as slow as you can go. Because not only are we not going to have efficient, optimized code, but we have to parse the code as we go. It's like compiling as you run. So you know how long it takes to compile a project. Imagine that going as you play instead. Okay, also no compile time error checking. So if you do have an error somewhere in your code, you're not going to find it until you encounter that line of code as you're trying to play. And then last, I've listed garbage collection again. These things will have a garbage collection system. It's part of what makes it so easy to use, but it has that downside of the major frame rate stall. Virtual machines. There's a vocab word, virtual machine. The way an interpreted script in particular works is it works inside of sort of an emulator of an actual computer. The instructions that you load in, they're not machine code instructions because it's not been compiled. Instead, they're just text. We take the text and we parse it and we turn it into machine code instructions. We don't usually go directly to machine code. Instead, we go into a code that operates in a virtual machine. An emulator really is what it is. And this virtual machine will have virtual registers and stuff like that that we will use to execute on the script and maintain the state of the program. But that means if one of your instructions causes a fault, it's the virtual machine that has the fault, not the actual machine itself. And so all we have to do then is, fire a little message. Hey, the virtual machine has some error and we're not able to run this script anymore. So we'll just reset your virtual machine and move on to the next script. And this is what makes it so crash resistant. The last thing I mentioned there, I don't have a slide on it, is Blueprint. Blueprint is somewhere in between there where instead of using text to articulate the script, we're going to use visual elements to represent that. Those are then saved out into a format that the engine can drive in a virtual machine scenario. So what are the pros and cons there? The biggest pro of a visual scripting system is the barrier to entry to people who don't have experience or don't feel comfortable in text editors with a programming language can use a programming language that is very visual and shows you the flow. If you've ever tried it, it's very cool, especially debugging can be quite interesting to see visual representations of how the program is flowing from one step to the other. As far as downsides, the other downsides apply. It is not going to be parsed in real time, so you'll get a speed boost over something like a Lua, which is probably parsed in real time. But it's still going to be running a virtual machine, so it's not as fast as something like a C++ direct code. That brings us to the end of this video. I'll see you in part 3, where we'll talk about audio systems.